So many of the results that we know for the two-dimensional plane actually carry over to three-dimensional space. Let me just show you two important formulas, the distance formula and the midpoint formula. Let's take a look at the midpoint formula first, which says if I have 2 points in three-dimensional space, and we usually label them, they have three coordinates, an x, a y, and a z coordinate. So if I have one point, x1, y1, z1, and another point, x2, y2, z2, I want to find the midpoint. If I take one point here in space and one point here in space, and I want to locate the point that's right in between, it turns out that that's not so hard to do. All I have to do is do exactly the same idea as we did with two-dimensional space, namely take the average of each of the coordinates. So in fact, the midpoint is going to be x2 plus x1 divided by 2, y2 plus y1 divided by 2, z2 plus z1 divided by 2. It's just the average of each coordinate, and that's the middle point. Great. The distance formula we already actually saw with respect to the diagonal of a rectangular prism, but it's the same thing as Pythagorean theorem a couple of times. The distance is just the square root of the squares of the differences in the x's, the y's, and the z's all summed together. So it's the exact same formula. If you notice, that is the formula you're used to seeing. That's the formula that you're used to seeing, and all we did is tack on the extra new dimension. So not a big deal. So to practice these, let's actually take a look at this question. Let's find the distance between these 2 points in space and find the midpoint of the segment who has these 2 points as their endpoints. So here we go. Let's try it. So to find the distance, we take distance is square root of, we look at the differences in the x's, so 2 minus 1 is 1 squared, plus 5 minus 3, that's 2 squared, plus 10 minus 4 is 6 squared. And so we see the distance is going to be the square root of 1 plus 4 plus 36, which is just 41. And so we see the square root of 41. So that's the length of the segment, line segment between this point and that point, and therefore that's its distance. The distance between those 2 points is the square root of 41 units. How do we find the midpoint? Well, that's easy. The midpoint, we just average. So we take 2 plus 1 and add them and get 3. Divide by 2 and we get 3 halves, or 1 1/2. 5 plus 3 is 8. Take 8 and divide it by 2, and we see 4. And finally, 10 plus 4 is 14. Take half of 14, and we get 7. So we see that the point that's exactly right in the middle between this point and that point has the coordinates 3 halves, comma 4, comma 7. Neat. So all the formulas that we're familiar with back in olden days of just the plane carry over pretty much the same in three-dimensional space.